Okay, so we're going to try this again. My name is Andrew Goldberg. This is my final project presentation. The first, I'm going to walk you through this hopefully as efficiently as possible. It begins with importing the data. Then we assign the Y variable to sale price, which is the dependent variable. I assign X to overall quality, which is an independent variable. Then we check out the skewness of overall quality, as we can see both in a skewness test and the histogram, it's right skewed. Going further down, we look at some probability questions. To interpret each of them, we have the percent of all the third and fourth quartile price houses that are in the top quartile in overall quality ratings, which is about 31%. We have the percent of all the houses that are both in the third and fourth quartile in price and the top quartile in overall quality ratings, which is about 15%. We have the percent of all the third and fourth quartile price houses that are rated in the lower two quartiles in overall quality, which is around 31%. And then we prepare the data for a counts chart frequency. We ask if the splitting of the training data in this fashion makes them independent, as you would assume. Both of those variables are dependent on each other. And if we look at probability of A times probability of B, we get about 8%. The probability of A given B is about 31%. They are not equal, so they are not independent. Then we run the chi-square test. First, we have to look at the quartiles. Then, because there's so many different pricing rows, it was hard to get 5 in each. So I created a smaller contingency table. As you can see, it's still not perfect, but it's better than it was. I grouped some of the pricing by the quartiles. If we look at the Pearson's chi-square test, the X squared is quite large and the p-value is quite small. So it looks like we can, again, safely assume that the data is, those two variables are dependent on each other and not independent. We then look at the descriptive and inferential statistics. This is the distribution of the overall housing quality. Again, it's right skewed. This is the distribution of housing sale prices. It's very strongly right skewed. It's more rare for one of the higher price houses to get sold or to exist, I would say. If you go a little bit further down, we can see again on a scatter plot, there's a upward slope. So again, they're very likely to be dependent variables with a notable linear relation. Looking at the confidence intervals at 95% for the X, which is overall housing quality, is between 6 and 6.1 with a mean of around 6.1. If you look at the confidence interval for the Y variable, which is the sales price, we have a mean of about 180,000 at 95% confidence interval. Its lower bound is at 17,006 or 176,000, and the upper bound is around 185,000. We play with correlation matrices. And then we look at the actual correlation. So I would say if we set the null hypothesis that there's no correlation and the alternative hypothesis that the correlation does not equal 0, we look in again, the p-value is very small, the significance value at 99%, so we can reject the null hypothesis. Getting a little ahead of myself, but The correlation is somewhere around 0.8, which is, as we expect, to be a little bit higher given these two variables. If we look at the linear algebra and correlation section, we play with correlation matrix, then we play with the precision matrix, and when we and then to conduct principal component analysis, first we take the log transform to soothe the data a little bit, and then we look at the head, the summary. Once we actually get into PCA, we can look at the coefficients. It's a little odd given that there's only two variables, but it says that the first coefficient regards the positive correlation between sales price and quality, meaning that the sales prices take into account demand for higher quality housing. Second coefficient seems to regard a negative correlation, which isn't entirely explainable with only two variables, but perhaps alludes to less demand for the nicest houses that are out of most people's budgets. If we look at the graph, the variances, it looks like the first principal component makes up most of the variance. The second one is a small fraction of the first. So we can rely pretty heavily on the first component. If we look at the biplot, it's very dense. And if I'm interpreting this correctly, the X and Y are fairly close, so that, again, it shows a pretty strong correlation between these two variables. Once we get into calculus-based probability and statistics, we check that the variable has a minimum value which is above 0, which the summary says it does. Then we run fit distribution. If we look at the exponential function, it's very strongly right-tailed. It has a similar exponential function to the histogram, which is right-tailed, although it's obviously not as strongly right-tailed as the exponential function. Similar to the exponential function, if we look at the ECDF curve, most of the variance is within the first 0 to 10, and then it quickly levels off. When we look at the quantiles of the exponential function, 5% is about 39. At the mean, it's about 4, and at 95% quantile, it's at about 17. To generate a 95% confidence interval from the empirical data, assuming normality, we use a t-test. The mean is about 6. 95% confidence interval is from about 6.02 to 6.17. With the quantiles at about 4, 6, and 8. Once we can see that the exponential distribution has a much larger spread, although they are somewhat comparable means. When we look at the modeling, we run a linear regression. First, I tried it on many of the, or first I want to play with principal components. So I looked at all the useful quant variables that I thought might help. I took a look at the histograms. I ran principal component analysis on them. And obviously the first component likely just means that, or alludes to just general living space and quality. The second principal component favors the amount of bedrooms and apparently years built, which might be when the largest or smallest housing may have been built, although I'm not completely convinced of that analysis. When we plot it, we see again that the first principal component counts for the most variance, second counts for some variance, and then not as much, and then we can stop probably somewhere around 5. If we want to just look at how each of these variables relates to each other, it's not as easily viewable on such a small screen, but I plotted all of the pairs, and you can see that some of the different variables, actually many of the variables have what appears to be a pretty strong relationship to each other. Then I went there with the linear model. First, I just trained a standard linear regression to all the variables. Then I used a stepwise function to see if I can improve it at all, going both ways. Sorry, my roommate is bothering me. Give me a couple minutes. Give me a couple minutes. Sorry about that. The looking both ways for stepwise regression, it suggests to take out first or year sold and lot front age. So I took those out for the next regression. It improved the R squared to about 0.78, and then I applied. I sent that data to Kaggle. As expected, the score was not particularly good, but you can check. It's fairly crude. My username is Deep Thoughts. Hopefully, I can end it.